In this video, I am going to talk about derivatives definition. So let's start off with an example. Let's say you are driving, okay? So you're driving from point A to point B this way, some path, okay? And let's say the distance between them, D, is equal to maybe 210 kilometers or miles, whatever unit you use. And let's say the time it takes for you to travel this distance is 3 hours. So what is the average velocity over this distance? Okay, so in going from A to B, what is the average velocity? So you know the average velocity is gonna be V is equal to distance covered. Okay, so distance divided by the time it took. Very simple formula, you know. So in our case, what is the average velocity gonna be? So distance covered from in going from point A to B is 210 kilometers, okay? And the time it took is 3 hours. So 210 kilometers and 3 hours. So the average velocity over this distance from point A to B is gonna be 70 kilometers per hour. Now that's over a window of time, right? What is that window of time? That window of time happens to be 3 hours in our case. However, what if we want to find out the average velocity over 1 hour? Can we do that? Okay, sure. So let's say after 1 hour you are here and you cover a certain distance and you do the same thing. Use this formula, distance covered divided by time. Can we do it over half an hour? Sure, we could do it over half an hour. You'll cover maybe this distance, okay, right here for half an hour. So this is for 1 hour and this is for half an hour. And again, follow the same formula, distance traveled divided by the time spent as it is here. However, if we take this idea and extend it to further, that means the window of time over which I want to find the average speed of an object, okay? If I shrink that window, what happens? Still, we can keep shrinking and still using this. And we can make this window of time as small as we wish. Or we can make this window of time arbitrarily small or limit. In limiting case, this window of time could approach 0. Now let's assume that this path can be traced by a function. So let's call that function f, and it depends on time. So let's say it's a function of time. So this path from point A to point B could be traced by a function f of t. So the average value in going from point A to B, we could find it this way. So let's say at point A, the value of the function is f of t, and after 3 hours of driving is going to be at point B, so the value of the function is going to be f of, let's say, t plus 3. So the average velocity, we could find it as f of t plus 3 minus f of t divided by the change in time, which is t plus 3 minus t, that is just 3, right? So it's going to be f of t plus 3 minus f of t divided by 3. The average velocity is given by this. However, our goal is not to find average velocity over a long window of time, like 3 hours. We want to find instantaneous changes. That means as the window shrinks to an arbitrarily small amount, what is the average velocity or instantaneous velocity? That we could find this way, by the way. We let this guy go to 0, right? Approach 0, not go to 0, approach 0. So, or the time approaches 0. So the way we do it, we let limit h approaches 0, f of t plus h minus f of t divided by h. Look at the similarity between this formula and the argument or the term in front of the limit. They are very, very similar. Only difference is that here we have some fixed number 3 in the denominator, and here we have a variable number which is h in the denominator, and h approaches 0, and the numerator is just the difference in the function value. So what happens here is this: as the limit goes towards 0, as the h value approaches 0, what happens to the function? What happens to the ratio of this difference in function value divided by the h, okay, or small change in time? So that ratio gives you the instantaneous velocity for an object that's traveling along a path given by f of t. And this idea, by the way, is not unique to this object. I have used this object as an example, a moving object. And this could be generalized to anything. So your function y is equal to f of x, right? Any arbitrary function. So the instantaneous change for this function at a particular point could be found, right? So that instantaneous change, by the way, we call it derivative, okay? Instantaneous change in the velocity, value of the function is called the derivative. And we define derivative as follows. We write it in many different ways. So one of the notations is df over dx, if f is a function of x. This is also written as f prime of x. These are the two most common notations. So df over dx is equal to limit h approaches 0, h approaches 0, f of x plus h minus f of x divided by h. So that's the derivative of this function. Y is equal to f of x, or the instantaneous change in values of this function, or the what we also call the rate of change, okay, also called rate of change, is given by this formula. Again, f prime of x is equal to limit h approaches 0, f of x plus h minus f of x divided by h. So this is the definition of derivative. I hope that this discussion was helpful. Thank you very much.